Hi everyone, this is the fourth installment of the Forestry Lunch Break series on tree planting. Unfortunately, we had an issue with recording the first minute or so of the actual webinar, so you missed out on the introduction. Who we have today is Dan Omdal. He works with the Washington Department of Natural Resources as a forest pathologist, and he's going to be discussing forest insect and disease issues in young forests. And what he's talking about here is the forest health triangle, which is a common tool that we use and refers to the three sides or three elements required to have a forest disease or a tree disease. And you have the environment, the pathogen, and the host. And when you have all three of these, you get a forest disease. So I'll let Dan take over at this point. I hope you enjoy the webinar. And as always, please feel free to reach out to myself, Patrick Schultz at WSU, with any questions. Okay.
And when a favorable environment provides those conditions where a pathogen can successfully invade a host. So this is the space in the center here that as forest managers, we're trying to avoid, either by eliminating the pathogen, alternating host species, or as best we can, modifying the environment. So diseases that are caused by living agents, like the mushrooms we have in the lower right here, we call those biotic diseases. Sometimes diseases are caused by abiotic agents, such as extremes in temperature or moisture. Some would argue that without a pathogen, you can't have a disease. So oftentimes we refer to these diseases or injuries as injuries, if you will. So for example, winter desiccation is a cold temperature injury that occurs when cold or frozen soils inhibit the uptake of water by roots, so that part or all of the seedling dies. As you see here in this slide, this is frost damage, and it's characterized by drooping and reddening of buds and new needles. Young trees can be injured very quickly, either in the spring when a late frost occurs after the tree dehardens, or even in the fall when they have not really acquired enough cold hardiness to withstand early frosts. And not surprisingly, there's a lot of variability in cold temperatures, not only across species, but even within species. And so we know that seed sources from high elevations and higher latitudes are generally more frost resistant than those from low elevations and lower latitudes. Moisture stress in the form of drought probably kills more planted seedlings than any other agent. So in Douglas fir, as you see in both of these images, damage usually begins at the top of the tree with wilting and bronzing of the needles. And so, the recommendation for planting more drought-tolerant families, especially on fast-draining soils and south-facing aspects, is really an important strategy for mitigation. Also consider thinning highly stocked stands to reduce water stress. For we know that dense stands generally more prone to drought stress, and we've discovered that thinning often reduces competition for water. So young seedlings can die outright, but sometimes larger trees have more resources available, and oftentimes, as you see on this Douglas fir on the right, the injury may not be severe enough to kill an entire tree, but as you can see here, with the top 2/3 of the tree dead, these injuries frequently leave trees in weakened or in vulnerable states. So the next condition we'll talk about is when weak pathogens and insects become opportunistic agents. In other words, generally they're non-issue in seasons of plenty, and frequently only become problematic under stressful conditions like drought. And a good example of that would be what we see here, which is a canker on Douglas fir caused by Phomopsis. And fungi in this genus generally considered weakly pathogenic. And by that, they're frequently only able to infect twigs and branches that are injured by frost or drought. And so, I don't know if you guys can see my mouse here, but we have a couple of twigs coming into the stems here and here that have been injured by drought or frost, probably by drought in this case. And these opportunistic fungi are able to invade these tissues. And you can see on the main stem, there's some necrosis or a sunken lesion, a canker, if you will, of dead tissue, where the fungus has been able to travel down through these stems and through these branches and enter the main stem. And so there's dead tissue here. And this image on the right, you can see where we scraped away the bark and you can see the brown tissue that's dead, but immediately adjacent to it, there's live, healthy tissue. And so as resources become available for the tree, as rain returns and growth resumes, then the vigor of the, in this case, these Douglas fir is able to keep these weak pathogens in check. An interesting situation with these opportunistic pathogens is there's often a lag time in symptom expression. So the damage that you see in these small Douglas fir likely occurred a year ago, potentially even 2 years ago. And so it's not uncommon for me to be out in a stand of young trees and it's pouring rain outside. And I'm looking at these lesions and I have to convince the landowner that they're there because there was drought. And I have to remind them that the injury likely took place a year ago and it took about a year for these fungi to make their way and do the damage that they've done. And if we waited another year, a lot of these cankers might have resolved themselves and may not even be visible. But for a time, they could kill the tops of trees or certainly some of the smaller lateral branches. So similar to these opportunistic fungi, there are beetles that are able to act in a similar way. And so many of us are familiar with bark beetles because of their ability to kill large swaths of forest trees in a single season, like you see in this picture on the left here. And this image on the upper right, these bark beetles, as you can see, they're generally hard-bodied insects, usually not much bigger than a grain of rice. And they lay their eggs beneath the bark, as you can see in the lower right here. And their larvae, when they hatch, they feed on the sugar-rich phloem tissue, which is just beneath the bark. Oftentimes they etch their galleries into the wood underneath the bark. But in so doing, they tend to girdle the trees and killing them rather quickly. So secondary bark beetles are a group of bark beetles that typically infest trees that are usually first weakened by other agents like root disease or drought. They're oftentimes able to do damage to trees that are under stress, but normally they lack the capacity to kill otherwise healthy trees. And three of them that we have here are Pseudohylosinus and a couple of Scolitis beetles. And during seasons of stress, it's really not uncommon to find these beetles associated with smaller trees that are dying or even the dead tops of larger trees. You can see the etchings of a beetle here, and frequently the beetles are gone by the time you discover this, and so their identity is often determined by the gallery patterns left behind by the adults and the larvae as they hatch and mature. Similarly, there's weevils that attack young stressed Douglas fir trees. This Douglas fir twig weevil is a common weevil associated with Douglas fir that have been poorly planted or that are growing on droughty sites. So this adult here lays an egg in the crotch of these small branches. The eggs hatch and the larvae mine out the tissue and frequently killing leaders and twigs and sometimes even smaller seedlings. Really more concerning are the root-feeding weevils that are attracted to weakened or stressed Douglas fir trees. And so black stain root disease is an insect-vectored root disease that primarily infects Douglas fir west of the Cascades. East of the Cascades, you're more likely to find it on ponderosa pine trees. And so management of this disease is primarily focused on preventing activities that decrease tree vigor or attract insect vectors. So for example, minimizing soil disturbance or avoid creating poorly drained areas during road building and maintenance, or avoid creating patches of wounded or stressed trees during logging activities. All of these actions weaken young trees, causing stress and predisposing them to attack by these really opportunistic weevils. Two other root diseases that you're likely to encounter in the forests of Western Washington here are, one is laminated root rot, so named because of the way it delaminates tissue that's been infected by the fungus, as you can see in this picture in the upper right. On the left side here, we have, I think that was about a 6 or 7 year old Douglas fir seedling that we pulled out of the ground just about a week ago. You can see there's a lot of ectotrophic, upon. So this is mycelium that's living upon these roots here. If you look really, really closely with a hand lens, you're likely to find this sedal hyphae, or what we affectionately refer to as little red whiskers. Likely need a hand lens in order to make that distinction. I don't know if you can see right up in here, there's some brown, crusty mycelium that's also indicative of Coniferporia sulfuracins. There's another little section down here. It's rather crinkly, and I sometimes say you will, if you're really quiet, you'll hear Pholinus long before you ever see Pholinus, or in this case, Coniferporia. Pholinus is the name that it was recently changed from, and prior to that, the fungus was Poria. The other one is Armillaria root disease. This is a species, Armillaria stoi, that's a very aggressive pathogen, has a very broad host range, and including all conifers, actually, hardwoods as well. In the fall, there'll be a brief season of fruiting, as you see these mushrooms that are gilled, often referred to as the honey mushroom. And off to the right here, you will see, once again, another 6 or 7 year old Douglas fir that we pulled out of the ground about a week ago. You can see up above here, this lightish, whitish resin. We refer to this as basal resinosis. It's the reaction of the tree to an infection. And we remove the bark just beneath that, and you can see this white mycelial fan, which is actually the body of the fungus, completely occupying the sugar-rich phloem tissue just beneath the bark and completely encircling the stem and killing the tree. So both of these fungi, both Armillaria and Coniferporia, they are really successful saprophytes. What that means is that they, not only as pathogens, can kill living hosts, but once those hosts are killed, they can live for literally decades on the roots and stumps of their victims. And so you can see this picture on the right here. This was an old Douglas fir stump that was cut some time ago. It's sun-baked, got a hard shell, but underneath the pathogen is still living, and next to it was planted a Douglas fir tree. It grew for a few years, half a dozen years, until the root systems became intermingled with the infected roots, and the fungus was able to move from its saprophytic phase, if you will, to become a pathogen, infect and kill this Douglas fir. So because of this ability, we often refer to Armillaria and laminated root diseases as diseases of the site. Once you get them on your property, they will persist for, dare I say, generations, certainly decades. And so management do's and don'ts around root diseases are really focused on, one, surveys to locate the pathogen, because it's not going away. Looking for bark beetles, they may be there one year and they're gone the next. Other diseases, they show up and then they move on as the weather or changes and conditions became unfavorable. But root diseases, they will persist on your site. So knowing where they are is really important. And then secondly, by removing the food base. So these fungi have preferences for hosts, and by maintaining these hosts on the site, in the case of Douglas fir, primarily in the Puget Sound lowlands here with Coniferporia, as long as there's a Douglas fir host, that it will support the pathogen on the site. And so the idea of starving these hosts by starving these pathogens by eliminating their hosts will go to great lengths to eliminating these pathogens from the site. And of course, a couple of don'ts. Although sometimes these root diseases can occupy entire stands, generally you don't see pockets more than an acre or two, generally scattered throughout a unit. So thinning's also generally not encouraged. Oftentimes we fail to identify those trees are infected, and as we change the canopy architecture through thinning, by leaving trees with infected roots, oftentimes they become vulnerable to blowdown and wind throw and whatnot. So the last condition we'll talk about is this one, where disease develops because the weather or the climate directly favors the pathogen biology. So in this case, the tree may also benefit from a favorable environment, and may in fact be better suited under the new weather conditions, but it's oftentimes just overwhelmed by the robustness with which these pathogens are responding to the environmental conditions. And so sort of the classic example would be foliar diseases. And generally, as we see in the upper right, warm and wet conditions in the winter and early summer are highly favorable for foliar diseases. And so this schematic here basically just reflects the disease cycle, sort of a generic disease cycle for most foliar diseases. And these pictures don't look familiar to you. It's because unless you've looked under a microscope, you wouldn't really know what you're looking at. But so these pictures were taken under a microscope, and you may recognize They are the surface of a Douglas fir needle. This, for example, this picture on the right, the pinkish one, these oblong-shaped objects are the stomates that occur in rows on the underside of needles. They kind of look like a hot dog bun, and those lateral cells are the guard cells, which protect that pore. And when it's hot and dry and the tree is at risk of desiccating due to drought stress, it will close those pores. But when it's now starving for carbon dioxide, it opens them up through the manipulation of these guard cells, and CO2 is able to enter. And so that's what you're looking at here, the surface of a Douglas fir needle. And then these objects on them are really the pin, the fruiting structures that are really not much bigger than the head of a pin. And so here's one that has erupted and releasing the spores, and they're really fragile and susceptible to desiccation, and so they're really dependent on free moisture, humid conditions in order for them. As you can see in this picture, one here has landed on the needle and it's germinated, and thread-like structure, you know, a couple hours in the sun and it's baked and it dies. And so as long as there's free moisture, it can germinate. And this one on the bottom here, you can see lots of threads of the hyphae that are exploring the surface. And what they're doing is they're looking for a pore, a stomate, to enter and begin to infect the needle. That's what you see in this picture on the lower left. These threads, this is a picture taken from inside the needle, and the threads there. So you can see that because of the spore structures are so fragile that they benefit from warm and wet conditions. And probably the most noteworthy of these foliar diseases is Swiss needle cast, a foliar disease that infects only Douglas fir. Hemlocks and other conifers are not favorable hosts to this particular fungus. But you can see a Douglas fir needle on the left here with these white dots. They're the rows of stomates that we talked about earlier. This needle on the right has all of these little black fruiting structures that are erupting from the pores. So this is a heavily infected. And what we did is we cut this needle in cross section. We laid it down on a glass slide. And this image on the right, you can see to the right here's the outer portion, and to the left is the inner portion of the needle. This area here is the stomate. You can see the two guard cells that are straddling this pore, but punching its way through the stomate is the fruiting structure of this Nothophaeocryptopus fungus. And so what happens is these fruiting bodies, they clog the stomates and they limit the ability of these needles to take up carbon dioxide. And that's critical because it's carbon dioxide that's converted into sugar through photosynthesis and then used to make wood, make new tissue, and grow the tree. So trees that are infected, as aptly named by needle casts, they tend to lose their needles. And so here's three situations here where one of the things we do is in order to determine the severity of the disease, we try to figure out how much needle retention remains on these branches. And so this upper right here, this is probably more of a situation where there is no foliar disease, no Swiss needle cast, and then a degree to the left where needle cast is present, and some of the older needles, as you can tell on the branch to the left here, some of these older cohorts, they're missing most, if not all of their needles. And then the one on the lower right where most of the needles, save for probably less than half of the current year's needles, are still present on the branch. Generally, we say if the needles are retaining more than 2.5 years worth of needles, there's not a significant impact, but any more than that, and you may observe significant reductions in growth to these infected trees. And let's see, I do Just a couple others, foliar diseases. They're really common, especially during cool moist springs. Another one that we saw a fair bit spring 2020 was this Melamstra occidentalis, which is a rust disease of black cottonwood and Douglas fir. So you can see here's the underside of a Douglas fir needle. You can see the little orange spores that are erupting from this needle, some of the damage that's left behind from older infections. And I put this picture on the right here because this disease was frequently associated because of the alternate host with black cottonwood. And so you can see the Douglas fir here heavily infected and the cottonwood just behind it. That's the alternate host. In the absence of the cottonwood, the spore loads are generally low enough so that you don't normally see any significant disease there. So I'll just, let's see, just some obvious silvicultural steps to managing foliar diseases, matching the right tree to the right site. If you're a Christmas tree grower, you're familiar with the fungicides that are available that act as protectants. And oftentimes the reaction for many is to fertilize these trees, the notion that a more vigorous tree will be able to tolerate these diseases. But what we've discovered oftentimes is that these fungi, which reside in the needles, often benefit from these applications, especially nitrogen-based fertilizers as well. And with that, I'll be happy to entertain any questions anybody might have.
Thanks, Dan. You did get one question from Steve. Is there a typical disease that affects blue spruce top center stalk and the death that works its way downward? So it sounds like it's getting the leader and then works its way down.
Yeah, there is. It's likely caused by an insect, and it's a weevil that infects the spruce. And just like the weevil that I show you on the Douglas fir, it's specific to that disease, to that host. Oftentimes you will find it. Let me see. I'm putting my entomology hat on here. In cooler climes along the coast, we tend to see less of it because oftentimes the fog belt along the coast will keep temperatures cool enough that it takes a longer time to complete a generation. And oftentimes further inland, the temperature gets warm enough and it accelerates the development of these spruce weevils that are often able to cause rather significant damage. One of the strategies oftentimes that I've seen is to grow spruce because it's a very shade tolerant species. For example, under alder. And oftentimes alder will provide frequently that level of shade to keep the temperature down and limit the development of those trees, of the mortality in the leaves of those trees. I also know that there are Canadians working on resistant spruce that can handle these weevils better, or maybe there's not so attractive to these spruce weevils as well. So that's what you're looking at. It's an insect for sure.
It's interesting. I didn't know about the spruce alder management. That's really neat. So it is about 12:30, but I did have one question for you to go back to the root rot. And if anyone else has questions, we can hang out for a little bit. But regarding root rot, what happens if you do nothing? And is it okay to do nothing?
Yes, it's okay to do nothing. In fact, it's been my observation that most silvicultural activities that favor the creation of stumps really promote root disease. So that's kind of crazy when you think about it. And when you say do nothing, what happens in the wilds, in the absence of any management, for example, is that a tree that gets infected with root disease and left to its own, it will fall over time, either as a function of being blown over by the wind or losing its roots. So it will fall over. And as it falls over, oftentimes the roots come out of the ground. And as the roots come out of the ground, they're exposed to the desiccation of wind and sun, which acts as a sterilizer and cleans the site up. And so sometimes the best thing to do is to leave it alone. Oftentimes I come across landowners where they see these trees infected with root disease, and their first reaction is to cut them. Well, what they've done is they have provided a safe harbor and residence for these pathogens for as long as those stumps remain in the ground. And they will persist, these fungi in these stumps, up until the day that you can put your boot through that stump. So that's a long time. So sometimes the best thing to do is, in fact, to do nothing. Doing nothing, however, oftentimes there is a time element. And sometimes if you're looking for these sites to sort of reclaim themselves, it may take a level of time that few of us can afford to invest in if your property is in fact designed for a financial return. So
yeah, so landowner goals are really important there. Yeah,
they are critical. I do see a question here. Is there a field guide that can help determine which insect and disease can be minimized by thinning? So for example, we talked about foliar diseases and the importance of climate in providing a suitable environment for sporulation, germination, and infection of spores. What we found is when sites are thinned, they tend to allow more air to move through these thin stands. When that happens, generally the humidity goes down, and as the humidity goes down and the site dries out, it tends to be less conducive to some of these foliar diseases. So for example, one of the reasons why oftentimes we recommend pruning western white pine from below is that most of the infections that we record of blister rust in white pine occur in the lower portion of the crown. That's often the portion that's closest near the ground, frequently growing within the brush, and often harboring higher humidities later into the day and longer into the season. So by pruning those lower branches, you remove a lot of that foliage, you allow the air to move through these stands, lowering the humidity, and then creating a less favorable environment for these fragile and fickle spores to germinate and infect. So another question, is there a field guide that can help determine which pathogen is infecting your trees? I know that there's lots of field guides. I have one here just on my desk, Field Guide to the Common Diseases and Insects, Pests of Oregon and Washington Conifers. Most states I know, or regions, have field guides. Of course, if you have access to the web, you can just use Google to type in maybe some symptoms, maybe the host, and likely you would come up with some examples of potential diseases that are affecting those trees.
There's the one out of British Columbia too that's been helpful to me. I don't remember. I think it's just called Diseases of Conifers of British Columbia. Have you used that one at all, Dan?
Yeah, I have. It's Common Tree Diseases of British Columbia by Eric Allen, Duncan Morrison, and Gordon Wallace. Yeah. Yeah, it's got really nice pictures, and there's lots of diseases that affect trees, literally hundreds and hundreds. But for most of us, there's probably a dozen or maybe 20 that if you learn those throughout the life of your stand, you'd be well ahead in managing any agents that might afflict your forests. So although it can be intimidating, there are some common ones to find out. So that list shouldn't be as long. as you might fear.
I just threw a couple links in the chat box to those guides that we mentioned.
Yeah, perfect.
Awesome. Well, if there's not any more questions, I'll go ahead and wrap up there. Thank you, Dan. Really appreciate everything you did to make this happen today. So
yeah, great. Thank you.
Yeah, hopefully in the future there'll be less technical issues.
Thanks. Yeah, great.
All right. Thanks, Dan.
All right, everybody. Take care. Bye-bye.